All right, so we're going to do a brief introduction to current. We're going to use the equation Q equals IT, where Q stands for charge, I stands for current, and T stands for time. First, let's take a look at electric current. Electric current can be defined as the rate at which electric charges pass through a given area. In simpler terms, you could also say that current is the flow of electrons. So I want you to picture like a pipe with water in it. Each drop of water could be seen as an electron, and so you can have a lot of water passing through the pipe, which would be a lot of current. You could have the water going through the pipe slowly, that's less current, or you could have it going quickly, that's more current. It's the flow of electrons. It's measured in amperes. You're going to see that as A in these word problems. It is the I in Q equals IT. So if you solve for I, you divide both sides by T. I equals Q over T, which is kind of like how velocity is, except it's charge over time. It's the rate that charge moves with regards to time. So since current is charge over time, let's take a look at what charge is. Electric charge is a physical property of matter that causes it to experience a force when placed in an electric field. It's measured in coulombs, and each electron has a charge of 1.6 times 10 to the negative 19 coulombs. Now, technically, electrons have a negative charge, but we're going to use a positive number for this course, because when we calculate current and all that stuff, we're going to end up with positive numbers. So we're going to use electron as having a charge of 1.6 times 10 to the negative 19. If you have the number of electrons, your total charge, Q, is the number of electrons times how much charge each electron has. 1.6 times 10 to the negative 19. To make this easier to remember, sometimes I think of it as people who owe me money. If everybody I loan money to owes me $5 and 10 people owe me money, how do I know how much money is owed? Well, I'd take those 10 people and I'd multiply it by $5 each. $50 is owed to me. So it's kind of the same thing with total charge. If each electron has the same amount of charge and you know the number of electrons, you just multiply the number of electrons by how much each electron has. That way you get the total charge. Electric charge is the Q in Q equals IT, and you don't need to solve for it. It's just I times T. So there's two ways to get Q. One way is if they give you the number of electrons. The other way is if they give you current and time. Here's an example. Current in a light bulb is 0.835 amperes. How long does it take for a total charge of 1.67 coulombs to pass through the filament of the bulb? Now, if you want, you can press pause here. You can try the question out based on what I've given you so far. Go ahead and do that. All right, so hopefully you've tried it out. Let's see what this looks like. So first of all, it's asking me how long does it take, which means it's asking me for time. Q equals IT, so if I'm going to solve for time, that's going to be time equals Q over I. The 0.835 amperes is I, it's current. That's down there. The 1.67 coulombs is Q, charge. That's right there. So we're going to put both of those in the equation, and you get 2 seconds. And that's it. Let's try another example. Free answer alert. This one's on the quiz for kids in my class. How long again? That's time. Q equals IT, so T is equal to Q over I. The 60 times 10 to the negative 6 amperes, guess what that is? That is current. So that's I. The 3.75 times 10 to the 14 electrons, that is not Q, but it gives us Q. Remember, each electron has a charge of 1.6 times 10 to the negative 19 coulombs. What does that mean for us? It means that Q is going to be equal to the number of electrons that they gave us times 1.6 times 10 to the negative 19 coulombs. So if you do 3.75 times 10 to the 14 multiplied by 1.6 times 10 to the negative 19, you get 6 times 10 to the negative 5. So that's how you're going to input that answer. So we have Q, and so we put that into our equation to get T. Now once you put that in your calculator, you get 1 second. Don't you guys hate those? You do all that work to get 1. So that goes in there, and we are donezo.